Hi, and welcome back to our course in college algebra. In this video, I wanted to discuss graphing absolute value functions. And in particular, we're going to talk about a method called the method of transformation. So as we've discussed already in the course, a graph is a very important way to represent a function. It immediately shows us the collection of all input-output pairs for the function. Remember, the x-coordinates of points on the graph represent the various input values that we can use. So the x value can be anything in the domain of the function, and the y value represents the corresponding output associated with that input. So what I'm calling the basic graph of y equals absolute value of x, it looks like this. Okay. Now, a lot of people actually get a little confused with the absolute value function. So I've seen people just replace this with just a plain old x. That's not quite true. The absolute value function gives you back exactly what you put in if you put in a positive x value. So you put 1 in, you get 1 out. So 1 comma 1 should be on the graph. If you put 2 into the absolute value function, you get 2 out. So on this side, the graph coincides with the graph y equals x. However, on the left side, it's going to look a little different. If you put negative 1 into the absolute value function, you get positive 1 out. If you put negative 2 in, you get positive 2. If you put in negative 3, you get positive 3. Okay, so the graph of the absolute value function looks like this. It looks like a V shape. So if you are dealing with a function that has absolute value in its rule, expect the graph of that function to be V-shaped like this. Now there's a pretty neat method for drawing graphs of absolute value functions pretty easily. Let me give you a quick example. Let's try this. Let's try y equals absolute value of x minus 3 plus 1. Okay, so a couple things that I want to note here. I'm comparing this formula to the basic formula right here. So you change the formula, that's going to change the graph. Now, fortunately, these changes happen in very predictable ways. Okay, so we replaced x with x minus 3. That is going to move our graph to the right 3 units. Okay, we'll see this a little bit more later on when we talk about transformations in general. Sometimes folks think that's a little bit backwards, okay, but if you take the input to the function, so here my function is the absolute value function, and I've messed with the input. I'm no longer inputting just x. I'm inputting x minus 3. So you mess with the input to the function, well, where are the inputs represented graphically? That's the x-coordinates. So you mess with the inputs, that's going to change the graph horizontally. In this case, it's going to move you to the right 3 units. And now here, you take the absolute value and then you add to that. So now you're messing with the output. Okay, so this is going to move you up 1 unit. So, to get the graph of y equals absolute x minus 3 plus 1, what I'm going to do is I'm going to start with this picture right here, and I'm going to shift the graph 3 units to the right and 1 unit up. Okay, so all the corresponding pieces of the graph will also shift. Okay, this will be a V shape with the point of the v right here at 3, comma 1. Okay, so changes to the function that look like this, replacing x with x minus something that's going to shift you to the right. Okay, remember it's backwards of what you might think, and we'll see more about that when we talk about transformations in general. Changing the outside, that's going to move you vertically. So change the inside, you're going to shift either to the left or to the right. Change the outside, you're going to move vertically, either up or down. Okay, let's look at a couple different examples here. So, another example. Graph y equals, let's make it absolute x plus 2 minus 3. Okay, notice I've made some changes, somewhat similar to what we had before, but not quite the same. So as we're doing this, we have to be picturing the way our basic graph looks, y equals absolute value x. So we should always have that picture in our head when we're dealing with these absolute value functions. In fact, I'm going to put that picture here. Some little dotted lines, just so we can visualize it. Okay, so that's y equals absolute x. Now, how's this graph going to look? Well, as you can probably surmise, over here, in the previous example, when we replaced x with x minus 3, that moved us 3 units to the right. Well, here we replaced x with x plus 2. That's going to move us 2 units to the left. Okay, so to the left, 2 units. When we had an extra number being added on the outside, that moved us up. Here we're subtracting, that's going to move us down. Down 3 units. Okay? So we're going to take this picture that we have right here. We're going to move it to the left 2 units. So we're thinking, okay, where's the point of this v? Originally it's at the origin. Move it to the left 2, move it down 3. Okay? And now kind of make sure we take the corresponding pieces with it, okay? So all the points on the graph. Left 2, down 1, 2, 3. 2 comma 2 is on the original graph. Left 2, down 1, 2, 3. Okay, so this is what our picture is going to be looking like right here. So that is the graph of y equals absolute x plus 2 minus 3. Okay, so the basic principles, and we're going to see this more when we talk about transformations in general, but the basic principles are if you replace x with x minus something, that moves you to the right. If you replace x with x plus something, that moves you left. The outside, changes to the outside of the function affect the graph vertically. If you add, it moves you up. If you subtract, it moves you down. So changes to the inside have the opposite effect of what you might expect. Changes to the outside, they work a little bit more directly. Okay, so you should be able to graph any function like that really quickly using the idea of transformations. You have to remember what the basic shape looks like, and then you can get your graph by shifting that basic shape.